Hi everyone, it's Coach Fred and I'm back, and today I'm going to be reviewing the coordinate points on the unit circle. And I would say that if you're not really comfortable with this idea, you should go back to this video on my review of special right triangles for before introducing the unit circle, because I go through the specifics when you have a hypotenuse of these special right triangles when they're one, because I'm going to go through it very quickly today. Here we have a unit circle. We had gone over number one, that a unit circle has a radius of 1. We know its equation is x squared plus y squared equals 1 squared. And remember, if you have a circle and you put it in the coordinate plane, then it's x squared plus y squared, because we're trying to find points on the unit circle. So if you draw a right triangle here, and this is the x, and this is the y, well then the coordinate here is x, y. All right, we talked about the things we're going to need on the unit circle are the degree measure or the radian measure, more likely the radian measure, but then we need to talk today about the ordered pair, or the coordinate point at each of those degrees. We spent the last two videos reviewing all the different degree measures and radian measures. Today we're going to focus on the reference angles, the 3 reference angles, and the quadrantal angles. I'm going to start with the quadrantal angles. So the quadrantal angles, again, are the ones that are right on the axis. Let me make this a little smaller so you can see it. And if the circle has a radius of 1, I think I made that a little too small. Let me make it a little bigger now. There we go. Stop. Okay, if it has a radius of 1, well then, this length is 1, so this coordinate point would be 1, 0. If I go up to the pi over 2, well, if this length is 1, because it's the radius, well then this would be 0, 1. And over here would be negative 1, 0, because I've gone onto the negative x-axis. And then down at 3 pi over 2 would be 0, negative 1. So those values you're going to have to know. Now we're going to focus on the 3 reference angles. So again, in class you should have learned where these came from. I'm going to do one of them, and then I'm going to give you the rest. All right, so I'm going to look at the pi over 6, or the 30-degree angle. So in your class, you should have drawn in the radius of 1, created a right triangle, and called this x and this y. Now, if you look at the 30, 60, 90 triangle relationship, we know across from 30 is normally s. The hypotenuse is 2s, and across from 60 would be s root 3. So using that relationship, well, we now have 1 is our hypotenuse. So across from 30 would have to be half of that, which would be 1/2. And across from 60 would have to be 1/2 root 3, which we would write as root 3 over 2. And so x is root 3 over 2. So that tells me that this coordinate point, this xy on the unit circle, would be, the x would be root 3 over 2, and the y would be 1/2. Okay, so let's go back to the unit circle. Let's put that in. Root 3 over 2, 1/2. And like I said, I'm not going to go through the rest. You can go to that video I indicated, and it'll show you how you get the remaining coordinate points. But it is good to know that sine and cosine take on different values in the unit circle. Cosine is always going to be the x-coordinate, and sine is going to be the y-coordinate. And again, you review where that came from in your class. Now, sine and cosine are what we refer to as complementary functions. That means that the sine of x is equal to the cosine of 90 minus x. So that means that the sine of 30 degrees would actually be equal to the cosine of 60 degrees, and vice versa. So that means if I have 30 degrees at pi over 6 is root 3 over 2, 1/2. Well, at pi over 3, it's going to be the complete flip of that, 1/2 root 3 over 2. And then the 45-degree angle, the pi over 4 angles come from the 45, 45, 90 triangle that you reviewed in class would be root 2 over 2 and root 2 over 2. So these 3 reference angles and the quadrantal angles are the only ones I spend time worrying about. Why? Well, because every other reference point is going to have the exact same coordinate. The only difference is going to be its positive or negative value, and that comes from where it lies in the unit circle. What do I mean? Well, 150 refers to 30 degrees, so I know that it's going to be root 3 over 2, 1/2. However, the x coordinates in quadrant 2 are negative, so it would be negative root 3 over 2, 1/2. If I go to quadrant 3, again, it refers to the 30-degree angle, so it's going to be root 3 over 2, 1/2. Except I'm in quadrant 3, where both positive, where x and y are both negative. And then if I go to the fourth quadrant, again, the 30-degree reference angle is 330, so it would be root 3 over 2, 1/2. Except x is positive, y is negative, so my 1/2 would be negative. And that's what I mean. If you know quadrant 1, then you know all of them. So all of my 45-degree reference angles, or pi over 4 reference angles, are going to be root 2 over 2, root 2 over 2. In quadrant 2, x will be negative. In quadrant 3, they'll both be negative. And in quadrant 4, the y will be negative. And the same thing with pi over 3. Again, pi over 3 is the reference angle. So at 2 pi over 3, I'm going to have 1/2 root 3 over 2. But again, x will be negative. In quadrant 4, I'm going to have 1/2 root 3 over 2. But they'll both be negative. And then in quadrant 4, it'll be 1/2 root 3 over 2. But the y will be negative. So really spend time getting to know the 3 reference angles for pi over 6, pi over 4, and pi over 3 in quadrant 1 and your quadrantal angles, and you'll be good to go. All right, guys, have a great day.